Welcome to qnawire.
In this problem, we throw a rock from a bridge. It reaches a max height and then comes down. 6 seconds after you originally throw it, it's at the height that you originally threw it from. And then a short time later, it's in the river. So before we calculate the final answer to the problem, we need to learn a little bit about the initial velocity that we throw the rock with. To do this, I'm going to examine the process from here until the top. If we know that it takes 6 seconds for the rock to reach here, then we know it must take 3 seconds for it to reach the beginning to the top, because it takes the same amount of time to do this as it does to come back down. So our time is actually 3 seconds for this. Our acceleration is a negative 9.8. Our final velocity is going to be 0, since the velocity here at this point, it will be stationary for a moment, and so it will be 0. And then our unknown is the initial velocity. We're going to use v is equal to v naught plus a times t. Our final v is 0. Our initial v is the unknown. A is negative 9.8, and t is 3. This gives us a v naught value of 29.4 meters per second. Now we know that this v naught is 29.4 meters per second, which also means that at this point right here, 6 seconds after it's thrown, it's also moving 29.4 meters per second, because the speed at which it initially goes up is the same speed that it's at when it comes down at the same point. And so now we want to solve for the speed here. And so I'm going to use the values that v naught is equal to 29.4. And actually it's negative, because we're moving down in this case. This v naught is going to be positive 29.4 because we're moving up. But once you call this v naught, it's negative 29.4. Our acceleration is still negative 9.8. Our x naught is 0 if I call this level 0. And then if I call that level 0, then this level down here is negative 28. And so x is negative 28. And these are in meters. Our unknown is v. And to solve this, I'm going to use v squared is equal to v naught squared plus 2 times the acceleration times the change in distance traveled. Whenever I plug in, I get v squared is equal to 864.36. That's just v naught squared. Plus 2, the acceleration is negative 9.8, and the distance traveled is negative 28. This yields v is equal to 37.6 meters per second. And technically it should be negative because it's still moving downward at that point. And that's the final answer.